Howdy, and welcome to the Spring Equinox 2022. That's some hours old. Satellite data shows entire Conger ice shelf has collapsed in Antarctica. NASA scientist says complete collapse of ice shelf as big as Rome during unusually high temperatures is sign of what might be coming. There is a picture, I don't get it. The ice shelf has broken off iceberg C38 and collapsed in Antarctica. Yeah, anyway. An ice shelf about the size of Rome has completely collapsed in East Antarctica within a few days of record high temperatures, according to satellite data. The Conger ice shelf, which had an approximate surface area of 1,200 square kilometers, collapsed around March 15th, scientists said on Friday. So it had happened before the equinox. Anyway, it would just ramp up the whole thing. East Antarctica saw unusually high temperatures last week, with Concordia Station hitting record temperatures of minus 11.8 Celsius degrees on 18th March, more than 40 degrees warmer than seasonal norms. The record temperatures were the result of an atmospheric river that trapped heat over the continent. Now let's see if that works. You just might have to keep in mind that weather is driven entirely electrical. So if you have an atmospheric river, it is a flow of energy, electrical energy. Ice shelves are extensions of ice sheets that float over the ocean, playing an important role in restraining inland ice. Without them, inland ice flows faster into the ocean, resulting in sea level rise. Dr. Catherine Golelo Walker, an Earth and planetary scientist at NASA and the Woods Hole Oceanographic Institution, said, though the Conger ice shelf was relatively small, it is one of the most significant collapse events anywhere in Antarctica since the early 2000s, when the Larsen B ice shelf disintegrated. It won't have huge effects, most likely, but it's a sign of what might be coming. The Conger ice shelf had been shrinking since the mid 2000s, but only gradually until the beginning of 2020, Walker said. By 4th March this year, the ice shelf appeared to have lost more than half of its surface area compared to January measurements around 1,200 square kilometers. Peter Neff, a glaciologist and assistant research professor at the University of Minnesota, said that to see even a small ice shelf collapse in East Antarctica was a surprise. We still treat East Antarctica like this massive, high, dry, cold, and immovable ice cube, he said. Current understanding largely suggests you can't get the same rapid rates of ice loss as in West Antarctica due to the geometry of the ice and bedrock there. This collapse, especially if tied to the extreme heat by the mid-March atmospheric river event, will drive additional research into the processes in the region. Satellite data from the Copernicus Sentinel-1 mission showed that movement of the ice shelf began between 5th and 7th March, Neff said. Yeah, you can check out those videos. Much of East Antarctica is restrained by buttressing ice shelves, so we need to keep an eye on all the ice shelves there. Prof. Andrew McIntosh, head of the School of Earth, Atmosphere and Environment at Monash University, said the Conger ice shelf had significant amounts of melting from the ocean beneath, which could have preconditioned for collapse. Ice shelves lose mass as part of their natural behavior, but the large-scale collapse of an ice shelf is a very unusual event. This seems to be a collapse rather than normal behavior. The collapse itself, however, may have been driven by surface melting as a result of the extremely warm temperatures recently recorded in this region. More evidence is needed to link this collapse to the recent surface melt was responsible for the Larsen B ice shelf collapse in 22. Ah, I jumped over one word, so that's why it didn't make any sense. More evidence is needed to link this collapse to the recent warming. Surface melt was responsible for the Larsen B ice shelf collapse in 22. The Antarctic heat event began on March 15th, said Alex Sengupta, an associate professor at the University of New South Wales. It looks like large parts of eastern Antarctica reached over 20 degrees warmer than normal. Prof. Matt King, who leads the Australian Centre for Excellence in Antarctic Science, said because ice shelves are already floating, the Conger ice shelf's breakup would not in itself impact sea level much. He said that fortunately the glacier behind the Conger ice shelves was small, so it would have a tiny impact on sea level in the future. We will see more ice shelves break up in the future with climate warming, King said. We will see massive ice shelves way bigger than this one break up, and those will hold back a lot of ice, enough to seriously drive up global sea levels. Scientists are particularly concerned about the future of the Florida-sized Thwaites Glacier, also nicknamed Doomsday Glacier, which is around 100 times larger than Larsen B and contains enough water to raise sea level globally by more than half a meter. The speed of the breakup of the Conger ice shelf reminds us that things can change quickly. Our carbon emissions will have an impact in Antarctica, and Antarctica will come back to bite the rest of the world's coastlines, and it may happen faster than we think. Yes. The timeline issue. I have been talking about this for many times. And it's interesting. Except all cookies. What's that? Go away. I suspect Totten Glacier mostly got nuked with warm snow during the mid-March Antarctic atmospheric river. The glacier did also lose a little 14 kilometers square snaggletooth at its calving front. Not a big deal, though. Maybe unrelated. Yeah, really nice. Yeah, this wasn't. There's nothing happening. Yeah, they don't say one single word about any cosmic cycle, Birkeland Currents, Poleshift, magnetosphere weakening, solar activity, induced energy, and all these kind of things. Nothing, not one single word. Or the possibility that glaciers might be lava streams made out of water, which would indicate at the start of a glacier there might be this kind of volcano thing. And if we think about the solar cycles and the earthquake activity, volcanic activity, about the different shells of Earth, atmospheric shells or spheres, how to put it, which are above Earth and inside of Earth. And there is one of those which contains water. And if there's a charge changing, if Earth's charge is changing, if there's less or more, the spheres will grow or shrink according to the charge differential. Or let's say the water in the ground would, for whatever reason, the sphere with the water in the mantle would grow. It would pour out of the ground, out of the mountains, out of all the geysers and volcanoes and where have you, out of the sea floor, 7,000 meters beneath the sea floor. There are, I guess, many of those wells where we just have fresh water pouring into the ocean from underneath. like we have elsewhere on our planet. So this might have something to do with polar ice melting and stuff as well. I don't know. I leave it here. Just stumbled across this. And remember, if the poles start to melt, it will snap over to the other side and it will get cold, but I will talk about that later. Thanks. Bye.